Next, methods for power factor improvement. The following devices and equipments are used for power factor improvements. First one is static capacitor method. Second one is synchronous condenser method. Third one is phase advancer. First come to the by using static capacitors. We know that most of the industries and power systems loads are inductive, that takes lagging current which decreases the system power factor. See the advantage of low power factor, disadvantage of low power factor. For power factor improvement purpose, static capacitors are connected in parallel with those devices which work on low power factor. These static capacitors provides leading current which neutralize or totally or approximately the lagging inductive components of load current. That is, the leading component neutralize or eliminate the lagging component of load current. Thus, power factor of the load circuit is improved. These capacitors are installed in vicinity of large inductive load, that is induction motors and transformers, etc., and improve the load circuit power factors to improve the system or devices. This one, figure 1, shows the normal load, we supply voltage I, the current, this is RL loads. So here a capacitor is connected across the loads. Here total current supposed to be supply voltage V, I dash is the total current. The current flows through the capacitor C, through capacitor C nothing but your IC, that is current across capacitor, and I is the current flows to the load, that is RL represented by I. So I dash is equal to I plus IC, means I dash is the vector sum of capacitor current and load current. Then this one is the figure 3, that is the phasor representation of the voltage, current and different currents. So this is the voltage V and I is the lax band voltage V angle under angle theta 1, and theta 2 is the angle between voltage V with respect to the total volt current I dash. So IC is the resultant current of I and I dash. Suppose here is a single phase inductive load which is taking lagging current I, and power factor is cos theta as shown in figure 1. Provides leading current, that is in figure 2, a capacitor C has been connected in parallel with the load. Now a current IC is flowing through capacitor which lead 90 degree from the supply voltage. Note that the capacitor, in a pure capacitive circuit, the current leads 90 degree from the supply voltage. In other words, voltage are 90 degrees lagging from the current. The load current is, first one is vectors combination of I, and IC is I dash, which is lagging from the voltage at theta 2 as shown in figure 3. It has been seen from figure 3 that angle of theta 2 is less than theta 1, that is angle of theta 2 is less than from the angle of theta 2. Therefore, cos theta 2 is less than from cos theta 1. That is, cos theta 2 is greater than cos theta 1. Hence, the greater than cos theta 1. Hence, the load power factor is improved by capacitor. Also note that after the power factor improvement, the circuit current will be less than from the low power factor circuit current. Also, therefore, before and after the power factor improvement, the active components of the current would be same in that circuit. The circuit, because capacitor eliminates only the reactive components of the current. Also, the active power in watts would be the same after and before power factor improvement. Next, advantage of static capacitors. Capacitor, first advantage, capacitor bank offers several advantages over other methods of power factor improvement. First one is the losses are low in static capacitors. Second, there is no moving part, therefore need low maintenance. Next, it can work in normal conditions, that is ordinary atmospheric conditions. Next, do not require a foundation for installation. Next, they are lightweight, so it can be easily installed. Disadvantage: the age of static capacitor bank is less, that is around 8 to 10 years, which with changing load we have to on or off the capacitor bank, which causes switching surges on the system. Next, if the rated voltage increases, then it causes damage it. Once the capacitor spoiled, then repairing is costly. Second method is synchronous condenser method. When a synchronous motor operates at no load and overexcited, then it is called a synchronous condenser. Whenever a synchronous motor is overexcited, then it provides leading current and works like a capacitor. When a synchronous condenser is connected across supply the voltage in parallel, then it draws leading current and partially eliminates the reactive components, and in this way power factor is improved. Generally, synchronous condenser is used to improve the power factor in large industries. Next, advantages: it is long life, almost 25 years. And next, high reliability, stepless adjustment of power factor. No generation of harmonics of the maintenance. The faults can be removed easily. It is not affected by the harmonics. Require low maintenance, only periodic bearing, greasing is necessary. Disadvantage: it is expensive, maintenance cost is also high, and therefore mostly used by large power users, and usually an auxiliary device has to be used for these operations because synchronous motor has no self-starting torque. Next, it produces noise. These are the disadvantage. Next, third one is by using phase advancer. The phase advancer is a simple AC exciter which is connected on the main shaft of the motor and operates with the motor's rotor circuit for power factor improvement. Phase advancer is used to improve the power factor of induction motor in industries. As the static starter windings of induction motor takes lagging current 90 degrees out of phase with voltage, therefore the power factor of the induction motor is low. If the exciting ampere turns are excited by external AC source, then there would be no effect of exciting current on the starter winding. Therefore, the power factor of the induction motor will be improved. This process is done by phase advancer. What is the advantage of phase advancers? Lagging KVR or reactive components of power of reactive power drawn by the motor is sufficiently reduces because the exciting ampere turns are supplied at slip frequency Fs. The phase advancer can be easily used where the use of synchronous motors is unacceptable. Disadvantage: using phase advancer is not economical for motors below 200 HP, about 150 kilowatt. Power factor improvement in single phase and three phase star delta connections. Power factor improvement in the three phase systems by connecting capacitor bank in delta connection or in star connection. So this one is the capacitor bank installed in parallel with the three phase load where the capacitors are connected in delta. Here the capacitor bank installed in parallel with three phase load connected in star.